All right, so what we're looking at here is L'Hopital's rule. It's actually what we're going to use. It's actually just asking for a limit as x approaches 1 of this expression here, which actually has an unknown function in it. But back here, they tell you that the limit of that function at 1. So you're okay. But at the beginning, you go ahead and you investigate this by just checking the limit of the numerator, and you discover that it's 0. And the limit of the denominator here, you also discover that that is 0. Okay, so you end up with a limit of 0 over 0, right? Because remember, plugging in for the most basic initial attempt for any limit is you just plug in the 1 and you kind of see what happens. And if you get a 0 over 0, you have a limit of indeterminate form. Okay, and you can use L'Hopital's rule. All right. Now remember, if you're doing an AP test here, then what you're going to want to do is you want to make sure you write out the fact that the numerator does limit to 0 and the denominator limits to 0, because these are the conditions that are required in order for you to employ L'Hopital's rule. Okay, so now that that's been written out, you can go ahead and employ it. So remember, L'Hopital's rule says you take the derivative of the numerator and you write it here, and the derivative of the denominator and you write it here. So the denominator, we'll do that one first. The derivative of x minus 1 is simply just 1. This is a product rule up here. It's like you have a third degree polynomial times some function, which is actually unknown. And so don't be nervous that you don't know that function. Just write it down and see what happens, right? So the limit would end up being the limit of the first, or sorry, the derivative of the first times f of x not differentiated plus the first one not differentiated times this one differentiated, so the second. And now what you end up, you just write f prime of x here. And you might be thinking, oh, shoot, I don't know f of x or f prime of x. But that's okay. Just keep moving through, all right? And now you can apply your limit. So as the limit as x approaches 1, you plug a 1 in here. And this is the 5, that 5 that came in from up here. You go ahead and put that because f of x limits to 5 as x approaches 1. So that's why that 5 can be placed there. And now this 1 gets placed here, and this one is a problem. But notice this actually becomes a 0. And so as a result, this f prime of x gets canceled out due to the fact that it's multiplied by a 0, and your limit ends up being 15. Okay?